You replace the blown 3-amp fuse, you power the system back up, and the new fuse pops immediately. Pushing another fuse into the board to see if it holds is a guaranteed way to waste time. Worse, repeatedly sending high-current short circuits through the system stresses the transformer and can permanently damage traces on the main control board. Instead of swapping parts by trial and error, we isolate the short circuit by disconnecting specific segments of the system, verifying the voltage, and testing individual branches. To execute this method properly, you will need a digital multimeter, wire labels, and a resettable low-voltage circuit breaker designed for HVAC diagnostics. By applying a rigid process of elimination, you can trace a fault directly to its source without destroying a handful of fuses along the way. Before making any electrical measurements, open the equipment cabinet and assess the physical condition of the unit. Turn off the line voltage to the system. Use your multimeter to verify that the power is entirely bed before you touch any low-voltage wiring. With the power secured, perform a close visual sweep of the cabinet. Look for pinched wires trapped behind access panels or thermostat wire insulation that has rubbed raw against a vibrating piece of sheet metal. Check for environmental issues, moisture pooling inside electrical enclosures, loose wire strands, touching a grounded chassis, or outdoor wiring chewed by rodents will often stand out clearly. A dead short severe enough to blow a fuse instantly almost always leaves visible evidence. Taking 60 seconds to sweep the cabinet often solves the problem before you ever connect a meter lead. If the visual inspection turns up clean, bring your focus to the main control board and power center to begin the electrical diagnosis. Plug a resettable low-voltage circuit breaker directly into the fuse terminals on the control board. This protects the board and transformer, allowing you to safely test the circuit without blowing another physical fuse. Restore line power to the unit. Set your multimeter to measure AC voltage and check the transformer's primary side to confirm it is receiving the correct incoming voltage. Next, check the secondary side. Place your meter leads on the R and C terminals to ensure the transformer is outputting approximately 24 volts AC. If the voltage sits at 24 volts with no load but drops significantly the moment a call is initiated, the transformer may have internal winding damage from a previous short circuit. Confirming a clean, steady power supply and securing the circuit with a resettable breaker guarantees that your testing baseline is accurate. The next step is to divide the control system exactly in half. We need to separate the internal cabinet components from all external field wiring. Patiently apply labels to every low-voltage wire on the board before you remove them. Trusting your memory here is a fast way to cross wires and introduce a new fault during reassembly. This diagram illustrates the separation. With the power off, disconnect all external low-voltage loads. Remove the thermostat wires, detach the outdoor unit control wiring, and disconnect any zone boards or external accessories. Now, restore power with only the internal wiring connected. As we see in this diagram, if the board registers a short or the resettable breaker trips immediately, the fault is inside the cabinet. If the board operates normally and the breaker holds, as the diagram shifts to show here, the internal components are healthy. The short is sitting somewhere in the field wiring. We have now proven that the issue lives on the external side of the system. Disconnecting the external loads cuts the diagnostic field in half. You now know exactly which side of the terminal block requires your attention. Now, we systematically reconnect the field wiring, one branch at a time. Always turn the power off before reconnecting a wire, then restore power to test it. This diagnostic flowchart maps the process. Step 1. Reconnect the R wire and restore power. If the breaker trips immediately upon connecting R, the fault is highly localized to the thermostat, the control wiring, or a zone board. If the breaker holds steady with R connected, initiate a specific operating call. Following the cooling path on the flowchart, if the breaker trips when the system calls for cooling, the fault lives in the Y wire, the contactor coil, or the outdoor wiring. Alternatively, if the flowchart logic moves to a damper call and the breaker trips exactly when a zone damper attempts to move, you limit your search to that specific actuator, its wiring, or a shared common. Taking careful note of exactly when the fault occurs tells you exactly which circuit to test next. Once you have identified the specific failing branch, turn off all power to the system entirely. Never test for resistance or continuity while power is still applied to the circuit. Doing so will destroy your multimeter and compromise your readings. Set your meter to resistance or ohms mode. Test each individual conductor in the failing branch to the common wire. Test each conductor to ground, and measure the resistance of any disconnected coils directly. If your meter reads OL, that indicates an open circuit with infinite resistance. If it reads extremely low, at or near 0 ohms, you have located a direct dead short. Because normal coil resistance varies significantly depending on the manufacturer and the component design, basic continuity beeps are not enough. Measuring the precise resistance coil has failed. With the fault pinpointed, repair the damaged wire or replace the shorted coil. Then remove your resettable breaker from the control board and install a standard 3-amp fuse. Turn the power back on and manually run the system through every operating mode, heating, cooling, and fan, to confirm the repair holds under all conditions. This checklist summarizes the discipline. Confirm fuse size, inspect wiring, disconnect loads, test each branch individually, repair the fault, and run all modes. Systematic isolation beats guesswork on every single service call. If this process helped you dial in your troubleshooting process, subscribe to the channel for more HVAC controls and electrical diagnostic guides.